graph of exponential function, and especially in the context of the question, how is that tested? So in this question 8, it's about a company that does firewood, and what it does, it cuts the wood and then leaves it to dry. So we get that. That's how it happens in life. And the function that we are introduced with, the value of y, that's our percentage. So here we have percentage of how much water is left, and value of t is number of weeks after how long the wood is in that warehouse. And obviously we understand from life, the longer it is, the drier it is. That's basically it. Okay. The companies start using a new warehouse. In this warehouse, the wood dries out faster. So that's the main bold thing that is said to us here. So what does that mean if it dries out faster? Well, let's say if in the old warehouse, after let's say 5 weeks, we had 20% of water left. So in this new one, after 5 weeks, let's say maybe we have 30, less. So let's say maybe we have 10 left, isn't it? That's the idea. That's what it means in practice. The following describes how the water content of the wood changes over time while it's drying out in the new warehouse. So again, you can see the function is the same. The only difference here, this one doesn't have number here, while here we had number. And here case constant and t is time in weeks from the start of the drying process. The diagram below shows the graph of my v function, the original, the one that old warehouse, for the given domain of t. And then on the same domain, sketch the possible graph of ut. So the problem we are having is that we don't have a value, we can't get the points, we have to understand the exponential function graph. So even without that, let's consider what we understand from the question. This is percentage of water, this is number of weeks, isn't it? So like what we said, let's pick a number. So let's say that, I don't know, let's say that's 5 weeks. So at 5 weeks, this is where the percentage of the old warehouse is. Where my percentage in the new warehouse should be? It should be what? Lower, isn't it? Because we are told that here it dries faster. So if in 5 weeks, I have in old warehouse 20%, let's say in the new one, I have only 10. So that means that for the same value here of x, I should have, let's say, I don't know. So this, let's say 20, this is 10. I'm making that up. So that's where my point should be. So what does that shows you? It shows you that the graph should be down. It's going to have the same limit, so kind of is going to be approaching the same on both sides, but basically it should be below the given. But that's what I'm saying, even without understanding that what's happening in exponential function when exponent change with the graph, we can understand that from the context of the question. We can think about life. The key to solve your big question is to think about it in real life scenario. Now, I'm just going to show you so that you can see how those graph looks. So here I've done, using software, I've done different graphs. So the green one is the original one, and then I change the exponent. So as you can see, as we change here this value, if that becomes what? Bigger, that's what happened. The graph will go down and it will go down, yeah? So that's what we need to understand. And that's where the next part is coming, saying that we have to write one possible value of k. So that's what I'm saying. In order for the graph to kind of curved more, now you can see that they are on both ends kind of in the same place. It's just that they have a bigger dip, isn't it? That's the idea. So in order for that to happen, this has to be a different value, the exponent. And it has to be smaller value. So it can be minus 0.08. because that is less than 7, it's too close. So let's say minus 0.009 or minus 0.1. It has to be, that value here have to be less. The less this value, the deeper that that graph will kind of deep, right? So, and now, like I'm saying, it's not an easy thing to know and answer. However, even without that knowledge, from understanding the context of the question and understanding that the wood, the longer it is, dries better, and understanding how to read the function and the graph and the x and y value, we are able to get actually the right graph in our exam.